Hello, this is Mr. Coates, and this is APES lecture number 46 on ramifications of global warming. So we've seen some of the data that supports global climate change, and now we want to see if indeed the Earth is warming and continues to warm, what are some of the things that will happen on the planet and things that we need to be prepared for. Let's look at this first graphic I have. These are the plant hardiness zones that the USDA puts out every year. And if you look at the zones here, the zones are changing. So this pink zone has gotten a little bigger this year. The red zone has gotten a little bit bigger in 2012. This green zone right here has expanded greatly throughout the Midwest. And so the plant zones where plants do the best is changing according to the USDA. And these maps are based on average temperatures in the United States. One of the things we have to be prepared for are droughts. Worldwide, droughts have increased from 15 to 30% since '79. So the decrease in water is not just from rainfall, but it also affects soil moisture, which affects our plant communities, and affects stream flow, which affects fish communities, obviously. It drops the water tables, which affects our groundwater. And loss of biodiversity can be a concern because of droughts. Increased desertification. Remember, desertification is when the soil loses its ability to be arable or plantable for crops. If we look at this graph down here, it shows the water levels of two of the most important water reservoirs in the United States, Lake Mead and Lake Powell on the Colorado River. These two reservoirs supply water to most of the southwest United States. And if you look at their holding capacities, this is when we started measuring holding capacity here. The dams were built actually earlier, but in 1965 were the lowest times here that we've got, and they increased throughout the 70s and 80s. We had a pretty big dip here in the early 90s, and then it increased back again in the late 90s. And now both reservoirs are at some of their lowest in recorded history. And this also leads us to see that this area of the Southwest is really hurting for water. This is only about 40 years worth of data. And once again, when we're talking about climate change, we want really long-term results. Unfortunately, these reservoirs haven't been around that long, but it does kind of give you an idea of where we are today. We've also seen an increase in ice and snow melting, and I mentioned this earlier when we first got into climate change. If we look at the world's ice, Antarctica contains about 75% of the world's ice. And Antarctica ice shelf, fortunately, has been fairly stable. It's starting to melt, but it hasn't been melting as much as the Arctic ice shelf has that's up here in this picture. The primary concern is the land-bound ice, which when it actually melts, the land then collects more heat and melts more ice. And this is a positive feedback loop for the melting of ice. Remember, albedo is that effect of the ice reflecting sun's energy back into the atmosphere. And if we get rid of the ice and snow, then a lot of that energy will not be reflected back in the atmosphere, leading to more global warming. We've talked about glaciers. I'm not going to go too much into that. We looked at glaciers in Alaska's Glacier National Parks earlier. This is the West Rongbuk Glacier on Mount Everest, and it shows you what the glacier looked like in 1921. So there's glacial ice coming all the way down toward you here in this area, and then in 2008 the ice has receded all the way back up this way, and it actually continues to recede back up the mountain there. A vertical loss of 340 feet of ice in the last century on Mount Everest. So we are losing glaciers even in the coldest areas of the planet. One of the larger unknowns when it comes to global climate change is how are the oceanic currents going to affect the Earth? If we go back to remembering the ocean currents and how important they are in moving heat around the planet, there is this worldwide global conveyor belt of temperature throughout the world's oceans. So you have warm surface currents here that bring warm water up into areas that are farther north. And as the water cools down and becomes saltier, then it starts to sink. And so the bottom water here is colder, and it moves across the bottom of the ocean and finally starts to rise as it becomes less salty and starts to warm. So you get this global movement of oceanic water through this global conveyor belt. And scientists are unsure about how this would be affected by continual warming. Some of the things that they think might happen, altered precipitation patterns. We've talked about how important those oceanic currents are for precipitation and temperature in localized areas. We could see increased storm severity and distribution, and we've kind of think that we've seen this already with increased hurricane force, increased cyclonic storm force, as well as increased tornado force in the United States. We've talked about droughts. Also, changes in these currents could cause increased cooling in areas. For example, if the Gulf Stream were to stop in this area or not even go this far, then areas that are up here would not be as warm as they currently are, and you could have a miniature ice age in those areas where this current has stopped. And so this is a big question mark as to exactly what's going to happen to these global currents if the globe continues to warm up. One of the biggest concerns with climate change is sea level rise. As the polar ice caps begin to melt and the glaciers begin to melt, that water has to go somewhere, and it's going into the oceans. Now, the IPCC has estimated that a rise in anywhere from half to almost 2 feet of sea level is very likely within the next 80 some years, 80 to 90 years. Now, if that occurs, then we could have some severe impacts on fisheries. We could have problems with low island areas. The Florida Keys would actually disappear. We'd have problems with agricultural lands. Some of them might become saltwater inundated and be unplantable at that point. We have a lot of people that live on the coast in the world, and these people would have to be displaced. Some of the data that supports the idea of sea level rise, there's some buoy data out there. This is a change in mean sea level given by the Topics Poseidon, which is a bunch of buoys that are read by satellites, and the satellites then extrapolate the data and they look at long-term changes. So this is from 94 to 2006 here, and shows you a 30 millimeter change here, which is 3 centimeters, which doesn't sound like a whole lot, but that's a pretty big change in sea level over a short amount of time. So this picture is from an area in New Zealand. This is during what they call a king tide. On the highest high tides, this area here gets flooded, and it didn't used to get flooded, and now every time there's a high or a king tide, they have to be careful of that. City of Venice in Italy is also very much affected by the highest tides, and every year the whole city gets flooded because of this. Let's get closer to home. In Florida, this is a map that predicts a 6-meter sea level rise. Now that's pretty extreme, but this is what they predict would happen if most of the major ice caps in the world would melt. It would be a 6-meter sea level rise. And you can see most of the major cities. This is all Miami-Dade area here. We got Jacksonville here, Panama City, Pensacola, and then of course our area here. Pretty much all in it inundated by floodwaters. The Keys would not be there anymore. Most of the Everglades would be inundated. And so this could be a worst case scenario if sea level were to rise plus 6 meters. Getting closer to home and lowering our expectations down to 3 meters here. So in Tampa Bay area with a 3-meter rise in sea level, what happens? Well, MacDill Air Force Base and most of South Tampa is flooded. This area right here, this is Port of Tampa, which is almost the lifeblood of Tampa Bay. It's all flooded. City of Tampa's major wastewater treatment plant is right in this area. We have most of, like I said, Port of Tampa and the industrial areas here flooded. The power plant is right here, and it's flooded out. There are numerous treatment plants in this area as well. In Ruskin, this is major fish habitat here. This could be changed significantly. And so there are quite a lot of problems if we get this 3-meter rise in sea level. And scientists predict this could happen by 2057. Now 2057 is quite a ways away, but most of you will be alive and will be around to witness if this actually happens. And this could be fairly significant economic impact here in the Tampa Bay area. We mentioned that extreme weather could be occurring, and we've kind of seen this over the last century in the United States with increased storm severity with storms like Katrina, which is this hurricane here, as well as Sandy, and then also the increased severity of snowstorms during the winter. And we'd have to deal with these increased weather concerns, and this would also affect insurance rates, which could be an economic problem for those people living in those areas with the worst probability of having these strong storms. As temperature increases, biodiversity will move based on the temperature change. We've seen changes in plant communities move north. As it gets warmer, certain plant communities start moving north to stay within their temperature tolerance levels. We're starting to see birds, their ranges also change. This is a map down here that the Audubon Society produced, and it shows how possible that the Baltimore Oriole range will change over the next 80 years due to temperature changes. And you can see that we get a fairly significant move of the Oriole population northerly if temperature continues to change. I mentioned earlier the planting areas in the United States would change. The planting areas in the rest of the world would also change. As crops move north, they might get out of those areas that don't have the best soil for them. They might be changed to areas that have more brittle and more acidic soil northward, and therefore that might change the productivity of the crops. Populations in the Pacific of zooplankton have dropped in places. Down here we have a study that was done about some zooplankton found in the North Atlantic, and this shows that there's two different types of zooplankton here, and the blue is a more northerly type of zooplankton, and the red is a more subtropical type of zooplankton, and it shows the occurrence and the amount that they could find per sample going through years. So starting in 1958 and going all the way through 2008, it shows a very visual increase of the subtropical population of this type of zooplankton with a huge decrease of the colder northerly population. That could also change major food webs throughout the world's oceans. But I hope that gives you some idea of possible ramifications of climate change. The idea is to look at these and be prepared for them. Most scientists nowadays say that climate change, that we can't really stop it to the point now to avoid some of these problems, and the best thing then is to be prepared for some of these problems. So I hope that was helpful. If you have any questions, please bring your questions to class.